got to give the people what they want. All right, Mr. Bass, right here. Let's get this. Let's talk about simplifying trig expressions. So this part of it, you just need to get it down in your notebooks, all right? So this is like a puzzle. There may be multiple things that you can try to make this happen. But again, I gave you a nice little flow chart that you can go through that I think will help you out 90% of the time. All right, so first, convert any Pythagorean, cofunction, or even and odd identities into a single function. So, in this case, look for things where it's like some function squared minus 1, or if you have like pi over 2 minus x's, look for those, or if you have negative x's, all right? Second, rewrite the expressions in terms of one function, if you can. So if you could write everything in terms of sine or everything in terms of cosine, all right? And then after you do that, does anything cancel out? All right, so third then, maybe you tried that. That didn't work. If you can't rewrite it in terms of one function, rewrite the expression in terms of only sine and cosine. And then when you get here, does anything cancel out? Or can you make some combinations of tangents or cotangents? All right, let's go on to step 4. All right, so now, after you do this once, you might need a second round of rewriting, okay? So maybe you rewrote something, you got somewhere closer, and then you got to do it again in a second round. And finally, step 5, there are multiple ways to get to the answer, so there isn't one right way. So again, like this is kind of like this puzzle. You can come at it many different ways, but I think if you follow these steps, you'll be in pretty good shape. So let's just practice some. You guys, I was really impressed with what you all did after watching the videos last class, so we're going to keep it going. Y'all got this. All right, so let's do number 1. It says the cotangent of x times the sine of x. So let's go through these steps. So you're like, okay, what does step 1 say? Step 1 says convert any Pythagorean, cofunction, or even and odd identities. Don't have any of those. Step 2 says rewrite the expressions in terms of one function. So cotangent, I could turn into cosine over sine, and sine I can't turn into cosine. So I don't want to get anything squared. So I'm not going to do step 2. Here's where I'm going to go. I'm going to go step 3. I'm going to rewrite the expression to get combinations of sine and cosine. That sounds good to me. So let's see here. Cotangent, I could call, I can call that cosine x over sine of x. And sine, and that's that, times sine of x is just sine of x over 1. Aha, look at this. Cancel. I end up with cosine x over 1, which is just cosine x. Boom. See how that works nice and pretty? Why don't you now try number 2? Sine of x times 1 minus cosine squared of x. Why don't you try that before I do it? I bet you can figure this out. All right, cool. So you tried it, you went through. So let's see. What does step 1 say? Step 1 says convert any Pythagorean, cofunction, even odd identities into a single function. This should be popping out to you as a Pythagorean identity. 1 minus cosine squared of x is actually sine squared of x. So you need to have those identities with you so you could look at it. Okay. So then you should be like, okay, I converted that one. Now I have that times sine of x. Well, look at this. I have sine of x times sine squared of x, right? So if I have x times x squared, what does that equal? X cubed. So sine to the first times sine to the second is sine to the third x. Yeah. All right. Why don't you try number 3. 3 is probably not probably, 3 is the hardest one on this page. But y'all got this. All right, so you paused it, you tried it. So the first thing I'm thinking is this looks like one of those, what does that say, even, odd situations. So I'm just going to look at this part. Oops, because it says, step 1 says convert any Pythagorean, cofunction, or even odd identities. All right, so I know that the secant squared of negative x is actually the same as this is the same as just the secant squared of x. Okay? So now I have the secant squared of x over cosecant squared of x. So now let's go to step 2. Step 2 says rewrite the expression in terms of one function. So let's see. Secant squared is the same as 1 over cosine squared. And cosecant squared is the same as 1 over sine. So I can't make them the same thing. So I'm going to go to step 3. Step 3 says rewrite the expression to get a combination of sines and cosines. I can rewrite these to get all sines or cosines. So again, the reciprocal of secant is cosine, so secant squared is 1 over cosine squared. And the reciprocal of cosecant squared is 1 over sine squared. All right, well, I can mess with this. Now I have 1 over cosine squared divided by 1 over sine squared. And I know to solve division, I have to flip this around. So 1 over cosine squared times sine squared over 1. Well, let's keep going. Let's multiply across. 1 times sine squared is sine squared. Cosine squared times 1 is cosine squared. Look, we got sine over cosine. And we got sine squared over cosine squared, which means we have sine over cosine, we should know, is tangent. So we just have tangent squared x. Boom, boom, boom. Easy work. Let's move on to number 4. Why don't you try to solve this without my help? I think you got it. I'm going to move this. Yeah, boom. All right. So you paused. You did this. You went through the steps. So let's go through these steps again. Step 1 says, convert Pythagorean, cofunction, evens, and odds. I see this right here, which makes me think about a cofunction? That's a cofunction. So the tangent of pi over 2 minus x, if you look back in your all your identities, that is the same as the cotangent. So this is actually the cotangent of x. So I get the cotangent of x times the secant of x. Okay, so let's go to step 2. Can I rewrite everything in terms of one function? Well, cotangent, I could turn into tangent. Secant, I can't turn into tangent. Cotangent, I can actually, the best thing to do is turn it into a combination of cosines and sines. So I'm going to go to step 3. Rewrite that expression to get a combination of cosines and sines. I know I could do that. So cotangent can be what? Cotangent is cosine over sine times secant I can write as 1 over cosine, right? Secant is 1 over cosine. We have those. All those are in our functions. So, boom, boom, look at this. Yeah. I end up with 1 over sine of x. And what is 1 over sine x? That's the reciprocal of sine, which is cosecant x. Boom, boom, boom. There are 4 problems. You are done. This is how we do it. Mr. Bass, I'm out.